So in this exercise, we're given a diagram. So this is my y-axis and this is my x-axis. And in this diagram, I have two vectors. One pointing this way. This is the A vector, which has a length of 3.60 meters. And it is at 70 degrees above the x-axis. And then another vector, B vector, pointing here and is at 30 degrees here and has length of 2.4 meters. In part A of the exercise, we need to write down the A and B vectors in I and J notation. So, part A vector in an I and J notation can be written as follows. The x components of A vector times I vector plus a y component times J vector. Now, how do we find this AX and AY? Well, AX is simply a projection of the A vector on the x-axis. So, if I take the end of the vector and drop a perpendicular here, the length of this side of the triangle is the AX projection. This is my AX. And this AX, if you just observe this triangle, is equal to length of the A vector times cosine 70. Similarly, projection of that vector on the y-axis gives us AY components of the vector. And again, by looking at this triangle, you can see that AY is equal to A times sine of 70. So now let's use these bits and plug them in here. So AX is equal to A cosine of 70 I vector plus AY, which is A sine 70 J vector. Now, we know that A has length of 3.6, so let's plug it in. 3.60 times cosine of 70 I plus 3.60 times sine of 70 J. Now you can use your calculators to figure this out, and this gives you 1.23 I plus 3.38 J. So this is the representation of the A vector in an I and J notation. Now let's do exactly the same thing, but for B. This is our A vector. So the B vector is written as Bx I plus By J, which is equal to B. And now, in order to get the right signs, whether plus or minus, when we set the angle in this equation, like here we set it 70, here you should set it starting from the x-axis. So even though here it says 30 degrees, but the actual angle with respect to the positive x direction is this angle. Now let me use a different color here. So this is the angle we're talking about. Okay? We're starting from the positive x direction. We always count it counterclockwise, starting from the positive x direction. So if this angle here is 30, this is 180, so in total this gives us 210 degrees. Okay, so the B vector is pointing at the 210 degrees with respect to the positive x direction. So, which means that Bx is equal to B times cosine of 210 pi. And then By is equal to B sine 210 J. So if you, well, then we can substitute for b. B is equal to 2.4. So 2.4 times cosine of 210 plus 2.4 times sine of 210. If you then use your calculators, you will find that this is equal to minus 2.08 I, and this is equal to minus 1.20 j. So this is our b vector. So now we have both a and b. So in part b of the question, we need to find c vector. So let's write it down. So part b, c vector is given as a combination of a and b as follows. So it's equal to 3 a vectors minus 4 b. Okay? So then this 3 times 3.38, and then minus 4 times minus 1.2. So I'm going to need to erase this now. If you then combine this using your calculator, you can get that I, this x component, is equal to 12.01 plus j, and the y component is equal to 14.94. Okay, so this is the I and j representation of the c vector. So now let's find the magnitude of c vector. So the magnitude of the c vector is equal to 12.01 squared plus 14.94 square root. So if you calculate this, this will give you 19.17 meters. Now, because the vectors here are measured in meters, so c has units of meters as well. So this answers part C of the question, whereas we need to find the magnitude, and now we need to find the direction of that vector. To find the direction, let's draw another picture. So C vector has 12 units along the x-axis and then 14 units along the y-axis. So it's pointing this way. This is our C vector, and we're looking for this angle. Let's call it theta. So just as we have shown it in the previous examples, angle theta is equal to the tangent inverse of opposite over adjacent. So in this case, this is equal to 14.94 over 12.01. And if you do the calculation, it gives you 51.2 degrees. So now we have both the magnitude and the direction specified by this angle. So that answers part C.